Hi guys, today we are going to talk about lesson 22 and I'm going to bring it to you in a little different format than we're used to. So I've put together a few problems from our workbook, but I put them on a Google document and I'm going to walk through the questions on a video this way instead of just doing it on a video where you're just hearing my voice today. So you are going to be using the highlighting tools. And that is why I wanted to model for you on the Google document so that after the video, you can then take what you learned from the video and help you on the problems that I'm giving you in class today. So today we are still working and learning about how to solve for rate, but specifically we are going to be using an equation to help us to solve these problems. And so I'll talk about that equation in just a second, but let's look at the directions. It says for each problem, highlight the distance in yellow, highlight the rate in green, and highlight the time in blue. Please show your math work and write your answer in a complete sentence. So the equation that we're going to use today is right here, guys. We're going to be using the distance. Distance is equal to rate times time. And sometimes you'll see, instead of this multiplication symbol, you might see just a dot in place of that multiplication symbol, because when we transfer it into an equation with just the variables like you see here, we don't want to confuse that multiplication symbol with a variable. So in this case, I'm using it as a multiplication symbol and not as a variable. So I could also just write it as D equals R times T, which again, D stands for the distance, R stands for the rate, and T stands for the time. Let's look at the first question. It says, I drove my car on cruise control at 65 miles per hour for 3 hours without stopping. How far did I go? So let's first talk about let's highlight what we see in the text. So I see 65 miles per hour, and so I know that this right here is my rate. So I'm going to be highlighting my rate in green. I also see 3 hours. Well, I know that 3 hours in this case is my time, and so I'm going to highlight that in blue. So how far did I go? I want to use this equation. So I want to use D. I'm going to just rewrite it for myself. D equals R times T. And then what I'm going to do is I'm going to plug in the information that I find in the problem to help me solve it. So I don't know what distance is. I'm going to be solving today for distance. So I'm going to just leave D as D because that's the unknown here. But I know that the rate was 65 miles an hour. And I know that the time in this word problem is 3 hours. So here what I've created is my equation then to help me solve the problem. So essentially I'm doing 65 times 3. And it is okay for you to use a calculator, so I'm just going to pull up my calculator here, and I'm going to just type in 65 times 3. That tells me 195, so I know that my answer here is 195, so D equals 195. And so essentially I've just solved how far did I go? Well, I drove 195 miles. So I could write I drove my car for 195 miles during those 3 hours. Writing my sentence in a complete sentence. Question number 2. On a road trip, the speed limit changed to 50 miles per hour in a construction zone. Traffic moved along at a constant rate, which was 50 miles per hour, and it took me 15 minutes or 25 hundredths hours to get through the zone. What was the distance in the construction zone? Round your answer to the nearest hundredth of a mile. So let's go back and let's highlight what we see in the text. Again, I'm going to highlight the rate. So I see 50 miles per hour. Anytime I see that per, that tells me that I'm working with rate, and I'm highlighting the rate again in green. So I'm going to highlight that in green. And it's also written for me right here, constant rate, 50 miles per hour. So I'm going to highlight that as well. So I know that that's the same. I also see 15 minutes, and then I see 25 hundredths hours. So this is the time. So I'm going to highlight the time in blue. Okay, and the question I'm asked is, what is the distance? So again, I'm searching this time for the distance again, just like I did in the previous question. And I know that I don't know what the distance is yet, but I know that that's what I'm going to be solving for. I'm just going to highlight that in yellow because I know that that's what I'm being asked to solve. Now, again, I want to use that equation, D equals R times T. So I'm going to just type that again for myself. So I have it for myself. And then what I can do is I can plug the information that I found from the word problem into the equation to help me know what I need to do to solve. So D, again, I don't know what D is because that's what I'm solving for, but I know that the rate was 50 miles per hour. So I'm going to type 50 times, and I know that the time here was 15 minutes, but I'm going to use this 25 hundredths of an hour. And so I'm going to put it into 2500. So 50 times 25 hundredths. And again, I can pull up my calculator to see what is that going to be. So I'm going to clear my calculator here. And I'm just going to type 50 times, and then I need 0.25 or 25 hundredths to see what that it gets. That gets me 12.5. I have to think about what does that 0.5 mean in terms of this answer. Well, I know that 0.5 represents a half. So that would tell me that the question again is asking what was the distance of the construction zone. So that tells me that the construction zone was 12 and a half or 12.5 miles long. Construction zone was 12 and a half or 12.5 miles long. All right, and I'm done. So by using that equation, it really helps me to solve my questions pretty quickly. Let's look at number 3. Number 3 says Chris Johnson ran the 40-yard dash in 4 and 2400 seconds. What is the rate of speed, rounding the answer to the nearest hundredth? So I'm just going to move this down a little bit so I have enough space for myself. All right, so let's go back and let's highlight again what's important in the text and in the colors that we're using. So if you need to, you can always scroll back up to the top to remind yourself, or you can write it down so you have it so you don't have to look up at the top. But I am going to be highlighting the distance in yellow, and I see that it tells me here how long Chris ran, or the distance that Chris ran. So he ran the 40-yard dash. So that is the distance that he ran. So I'm going to put that in yellow. I also see time here. So the time that he ran his 40 yards was 4 and 2400 seconds. So, and my time is going to be in blue. What is the rate of speed? So this is what I'm being asked to solve for. So I'm being asked this time to solve for the rate as opposed to the distance like I did in the previous questions. But I know that the rate is going to be highlighted in green, so I'm just going to go ahead and highlight the question part in green because that is what I'm being asked to solve for. So let's just type out that equation again. Let's look at it. D equals R times T. Again, R standing for rate and T standing for time. And let's plug in what we know from the word problem. So this time I'm given the distance. So I'm already given what D equals, and I know that D equals 40. So I'm going to type 40 there. 40 equals, now R, I'm not given R. R is the rate, and that's what I'm solving for. So I don't know what R is yet, so I'm going to leave R just as R because that's my unknown. But I do know the time that Chris ran. So he ran the 40-yard dash again in 4.24 seconds, or 4 and 2400 seconds. So let's look at this. This looks a little different from our previous problems because in our last two problems, we were able to just multiply R times T to get to our answer. However, in this case, I can't do that because I'm solving for R. So when I have an equation that looks like this, I'm actually going to end up doing the opposite of multiplication. And I know that the opposite of multiplication is division. So I'm going to end up dividing, just like we've been learning how to solve for rate. We've been learning that rate is division. We divide. So I'm going to divide that 40 by his time of 4 and 2400. So let's see what that's going to help us to solve for what R is equal to. So let's pull up our calculator again, and let's just type in 40 yards divided by his time, 4.24. And so his rate, oh, we get this big, long, crazy number, but it does tell me here, round any number to, or any answer to the nearest hundredth. So I want to look at the hundredth there, which is the 3, and I'm going to look at its neighbor, the 3, and the 3 is either going to tell the previous 3 to move up to a 4 or stay the same. So in this case, the 3 is going to tell the 3 to just stay the same. So my answer is going to be 9 and 43 hundredths, 9 and 43 hundredths, and that's going to be yards per second. Okay, because that was what I was searching for. How many yards did he run per second? And so I can write my sentence now. Chris Johnson rate, Chris Johnson's rate was 9 and 43 hundredths yards per second. All right, last question. Question 4, it says, using your answer from number 3, how many yards would Chris have run in 1 minute? All right, so this is a little different. How many yards? So yards would be, again, my distance. So I'm going to put that in yellow. And 1 minute here is my time. I know that that's my time, so I'm going to highlight that in blue. But one thing I have to think about is if I know his yards per second and I'm trying to figure out his distance for 1 minute, I can convert 1 minute. So if I know that 1 minute is also equal to that blank number of seconds, I know that it's equal to 60 seconds. That's going to be key. I have to do that little conversion there to help me to solve this problem. All right, so let's think about this problem. All right, so we know, again, we're going to use the same equation. D is equal to R times T, or distance is equal to rate times T. And let's think, we are solving for how far he ran in 1 minute. So the distance is the unknown in this case. So I'm going to leave just D as D. But I know his rate from my previous problem. So his rate, again, was 9 and 43 hundredths yards per second. So that was his rate. So I'm going to put 9 and 43 hundredths times, and then I think, okay, well, 1 minute. This was his rate per second. So again, if I want to figure out if in 1 second he was able to run 9 and 43 hundredths yards, how many yards would he run in 60 seconds? So I'm going to put 60 here. So look at the math that we have to do. We simply have to do 9 and 43 hundredths times it by 60, which is also equal to that 1 minute. Let me pull up my calculator again. And I'm going to type in 9 and 43 hundredths times 60 to get me my distance. Wow, that's a lot of yards. So Chris was able to run 565 and 8, or I could say 80 hundredths yards in 1 minute. So let's write that out again. So D is equal to, it was 565.8, and I'm going to put a 0 behind it to make it 80 hundredths. And so there I know I could write my sentence. Chris ran 565.80 hundredths yards in 1 minute. All right, so again, guys, we are using that equation. Again, the equation is D distance equals rate times time. So, or D equals R times T. We're using that equation to help us solve these problems. So now what you're going to do is you're going to move over into the classwork. The classwork looks like this. You're going to see it in your Google Classroom. And you have some problems here. So these are problems right from the problem set. I'm giving you a little bit more space in between them to show your work. And then you're going to do the same thing. You're going to highlight the distance in yellow, highlight the rate in green, and highlight the time in blue. I did the first one for you. And then again, you want to use that equation as you solve. So just like you saw me setting up my problem with each one, D equals R times T. You want to do the same thing and plug in the information that you're finding from each word problem to help you solve the word problems here.